Okay, so we can see here that on this motherboard, we kind of have these three main components that together are really doing the majority of your work on the computer. So first we have the CPU, which we saw plugged into that slot, and we said that this handles all of the processing in your computer, since the CPU is the central processing unit. Now next, kind of in our hierarchy here, we had the RAM. And the RAM, remember, was our short-term storage, so where programs can store data. And finally, the largest capacity is the hard drive, and that's where you can store all of your files for long-term usage, and they won't go away, for example, when your computer turns off. So let's start with the CPU. So we've said a few times that this is really the heart of your computer. So when you do something on your computer, like click on the Google Chrome icon or click on the Microsoft Word icon, something has to happen in order for Google Chrome to start appearing on your monitor. So the CPU is really what's going to make that happen. So the CPU's job is to execute instructions. So a program like Google Chrome has a set of instructions. And one of these instructions might say something like put the back button in the top left corner, or use this method to display a web page. And so these are the types of instructions that are going to be sent to the CPU. So for example, CPUs could look something like this. So they're all kind of in the general same shape, this little small green chip. You can see they have a bunch of pins at the top that kind of slide right into the motherboard. But as we said, there are different brands of CPUs, just like there might be different brands of operating systems or computers themselves. So we have some Intels on the right and also an AMD on the left. And they look a bit different, but at the end of the day, they really do the same thing. They're responsible for handling all of the instructions that some program will send to your computer. So of course, CPUs didn't always look like this. So this is one of the first computers ever developed. This is called the EDVAC, or also you might have heard of the UNIVAC. They all kind of look like these giant computers that sat in a giant room, and there's no hope of having one of these in your home. And really, the original goal of these things was to help out the military. And so organizations like the Army or the Navy needed to perform computations related to things like shooting missiles and other unhappy things. And just involved doing a lot of math that humans didn't want to do themselves. And so this was developed in the early 1940s. And what this could do is perform things like additions and multiplications. And for example, this could add two numbers together in 850 microseconds, which might seem fast, but we'll see really quickly that it's not so fast anymore. So this one in particular happened to be developed by the UPenn. And this weighed in at 9 tons and covered 500 square feet. So don't want to bring that to class. So another really early computer is actually developed a little closer to home. If you actually head down the street to the Science Center, and you kind of walk in those back doors, you might see this right on the first floor. So this was the Harvard Mark I. And this is also one of the really, really early computers developed in the mid-1940s, again for use by the Navy to perform Navy calculations. And what's special about this is that this could now, rather than just being given two numbers to add or do these simple math operations, this could actually start executing procedures of instructions. So rather than just giving this a single thing to do, we could actually give this a whole shopping list of instructions to execute stored on physical punch cards that you could actually feed into the machine. And now we could actually do some more complex operations that were more simple than math. So if you wanted to perform an operation like a logarithm, for example, that actually took over a minute to process using this thing. So you probably don't want to be browsing the web using this kind of CPU. So the CPU's main job, as we said, is to handle the execution of processes. So by a process, I mean a program like Google Chrome or Microsoft Word or maybe your email. So if you open up, if you're on a Mac, you can open up a program called the Activity Manager. If you're on a Windows, you might hit Control-Alt-Delete to bring up this thing called the Task Manager. And on the Task Manager Activity Monitor, we can see all of the processes that are currently running on the computer. And so right now, I have a whole bunch of different things running. You can see here that I have Keynote running for a slideshow. I have my Finder open so I can browse files. I have a bunch of Google Chrome stuff so I can browse web pages. So the CPU has to handle managing all of these processes at the same time. So really, we're later going to see that we have each program has a set of instructions. And the CPU has to worry about all of these different streams of instructions coming in at the same time, because if I have Microsoft Word on the left-hand side of my screen and Google Chrome on the right-hand side of my screen, I don't want only one to be working at once, right? I might want to start multitasking and having both of them working at the same time. So one of the CPU's big jobs is trying to figure out, how do I make sure that each of these processes gets a fair amount of time? Right? We don't want Microsoft Word to take over and make my whole computer unusable. I want to make sure that each of these processes has some fair scheduling system. So if I come over here in this right column, I can actually see what percentage of the CPU this is using. So in all of my CPU cycles, this program here at the top, which happens to be the Flash player, happens to be using between 5 and 7% of my CPU at any amount of time. So I can also do things like, rather than showing all of these processes, I can say, well, I only want to show the inactive processes. So these are actually all of the processes on my computer that aren't doing anything right now. They're just kind of sitting there. So if I sort by name, we can see here that one of those processes happens to be the dock, which is kind of jumping around. But the dock, remember, on OS X, or on Apple's operating system, is kind of the equivalent of the start menu on Windows, where all of you can switch between windows and launch new applications. So right now, because I don't have the dock open, it's just kind of sitting there. If I instead, I scroll down here, suddenly the dock pops up. Suddenly, from the left-hand side, the dock is no longer inactive, right? Because I've just hovered over the dock, and I've kind of said, this process needs to do something now, so you need to show me my dock. Suddenly, this process has gone from doing nothing to doing something. And it's the CPU's job to make sure that we can manage that. So the CPU needs to make sure that it can have both all of these inactive things running in the background, all of which are still pretty important to my computer running, but also know when it's important to switch an inactive process that's just kind of sitting around to an active process. So you might also have heard of the task manager or this thing as a way to kill processes. And what that means is that if a process has kind of stalled or it's hanging because of some problem with it, Microsoft Word is trying to open too large a file, or maybe Google Chrome, your tab crashed, as you might have seen before. From this application here, we can send a kill signal, which says, I don't care what you're doing right now, I just want you to go away. So if your computer's ever stalled or it's suddenly slow for some reason, this is probably one of the first places you want to turn, no matter what operating system you're on. Because then, if the little X in the top left or right-hand corner of whatever program you're using isn't responding, well, you can use this thing to say, tell the CPU, I want you to kill this process, or the process that is being used by this program. And so we can see, if we switch back to all of these, that we don't necessarily just have one process per program. So here are a bunch of things that Google Chrome is doing. And so something Google Chrome does, in fact, is it creates different processes for different tabs. So that means that it's kind of treating each of your tabs as kind of a separate program. And the reason I might want to do this are for a couple of reasons. So if one of those tabs crashes, for example, we don't want the entire Chrome browser to crash, right? If suddenly we just had this one big process for Google Chrome, and one part of that process crashed, the whole thing is gone. So instead, something Google Chrome did is they said, OK, well, I want you to treat each tab as its own process. So if one of you crashes, that's totally cool. Because not only are my other tabs in separate processes, but the Google Chrome itself, with that little icon, is in another process entirely. And so this was kind of a cool idea that Google Chrome came up with, and now other browsers like Firefox and maybe Internet Explorer, who knows, also adopted this idea. So it's just a nicer experience for you at the end of the day, because in the inevitable event that Flash player stops working in a tab, your whole browser doesn't crash, and you can still keep watching other cat videos. OK, so